Hello!
Hello!
Welcome to day 10. I know it's day 10 already, goodness.
Of the PiHut Advent.
I think I'm going to open today's.
Yeah, go ahead.
It's been a few days since I got to open one. What have we got in today's? Okay,
More mail to mail.
I see more mail to mail. I see a resistor.
I see weird block things.
I know, what are they? Let's have a good look. Maybe there's some kind of optical sensor?
No idea.
Gonna guess before I look. Okay, so we've got a resistor. One of those is an optical diode and one of them is an optical LED, as in one of them's transmitting, one of them's sensing. So
No
like
idea.
a transistor, optical transistor, like the one we did earlier with the light sensing, remember?
More of the exact same mail to mail.
I think those will go like this. Let's have a look.
Breaking beams, day 10.
So I wasn't wrong about optical sensors. So we seem to be doing a lot in terms of security sensors. I think we're getting into this full-on Santa trap territory here with like tilt switches and beam sensors and light sensors.
Santa's not going to have a fun time at this house.
Well, it depends what tune we play at him.
Yeah.
Beam break sensor with male jumper wire ends. We've got a resistor and we've got 4 male-to-male jump wires. Okay, cool.
What's a beam breaker?
There will be one of these will be creating an infrared beam. The other one will be sensing it, and when you break the beam, then you get a signal.
Oh, that's what it means.
Finger tap timer. Okay.
So we can just unplug that thing.
Right, and on the mini breadboard.
Tiny one.
Okay, my guess is the one with 2 wires is the emitter, and the one with 3 wires is the sensor.
Oh.
We've got what appear to be ground and voltage for both the emitter and the sensor, and then the actual sensor output cable. 4 pins in there.
About how the wires are a bit stiff.
Sometimes the holes are stiff. The thing is, under these, each set of holes, there's a little spring. There's a little spring that grabs like this, and then you push your wire and it forces the spring open. Yep. Here.
You got the
Okay, we've got a resistor.
To the red wire. I'm still wondering what's going to be in the big box of day 12.
4 pins, of which they use 3.
They just love giving us extras.
Well, guess it is Christmas. The yellow signal wire is going to go into same old GPIO 26 pin. That makes it easy. It makes it easier to find it, which means the purple will be our voltage pin.
And the brown will be ground.
Okay, so look, those 3 wires go off to there, so that's not too much of a tangle. And then we've got the 2 sensors coming out here. Basic break beam program. Need them on a flat surface with the heads facing each other about 15 centimetre apart. And we can use some
How are we going to do that?
blue tack or tape.
Oh, should I quickly get some blue tack?
We'll find some blue tack.
So here's a little bit of blue tack. It's actually white tack. They just wanted to brand something different.
1 beam there, and
We're not going to use a ruler to measure this.
going to be there, and we can break the beam there.
So we're going to copy this, and what this will do is it will set beam to our pin 26, sleep for a little bit, and then if the beam is broken, it will print something. Let's have a look. Save it as day 10, beam broken. .py. I can't actually tell what's happening because it just says beam broken.
I have stuck the breadboard down with a little bit of blue tack, and that means that the self-adhesive backing is going to get in the way a little bit. And I'm thinking, just so it doesn't all fall apart, going to do the same with this small breadboard.
Blue tack the wires.
Correct.
We're going to blue tack the wires.
I'm going to blue tack the wires so they will not get in their own beam.
That's happened.
Yeah.
Oh, I forgot to stop. It's probably just been going on for like 2 hours.
That's a much neater way to lay this out. Okay, so what we'll do, explain the change you've made to the go.
So I've just added this extra print line so that we can tell when the beam has been broken.
Isn't that going to still run when inside the same if? perhaps put a 1 or a 0 in those, I don't know. So 0, and if I break the beam, 1. There we go, so we can see, we've got the graph here, we got...
That's pretty clever. What if I put this clear bag?
Yeah,
It doesn't
clear
count
bag.
it.
Whereas the blue tack,
Well,
really
yeah.
nice and opaque. But it's enough to let the beam through. The beam is actually going to be reasonably strong. Going to detach this.
I want to see the beam.
Can we see the beam? Nah, this phone's got a filter on it. Okay, some cameras don't have filters so you can see the beams.
I can't see the beam with my eyes.
Of course you can't, it's infrared.
Well, if we can't see the beam, then why should the camera be able to see
So some cameras do not have infrared filters on them, and therefore it'll actually saturate their sensors, so you get a bright, purpley, ready light.
Activity 2, break beam height score game. Counts the number of times that you break the beam within 30 seconds. We're going to need a test subject for this.
Ah, I see. Epoch is...
Timestamp widely used in computing and is the number of seconds that have elapsed since 1st January 1970.
Yes.
Why? That's so
I think
random.
it's got a lot to do, possibly something to do with IBM computers.
You're
Would be my guess.
curious, try the very short code to see what an epoch looks like.
Now this is going to be kind of interesting on the Raspberry Pi Pico because that does not have a real-time clock or a battery in it. So I think it'll show the number of seconds since the Pico has been turned on. So I think it'll show the number of seconds since it was turned on.
No.
Right, so that's the number of seconds it thinks since it's happened since Epoch.
What if I Google it?
That is what seconds since Epoch would roughly look like right now, so I don't know quite how to pick that up. Maybe it's based upon when the Raspberry Pi Pico was made. You could go to Google and do a Epoch converter, Unix timestamp converter, and paste that number in. Okay, timestamp to human day.
Just now.
December 2021. Okay, so somehow,
Correct.
why would the Pico have that? That's interesting. I don't quite understand why the Pico would know the current epoch, unless it was sent with code we updated with, but otherwise, and counting since then. Otherwise, I don't see why a freshly turned on Pico would know how many seconds there were since epoch. Code is a bit longer, nothing scary or new. Setting up pins, PWM, creating some variables, things you've all seen. If statement checks the timer. And if the time isn't up, checks another one.
Game on. What's next?
See if you can beat
Challenge
staff record
family
times.
Oh, these are the staff record times.
Lol. Okay.
I bet that I'll be able to beat them. Okay, here's the code.
Put it in.
And
Okay, there's a beep for game start. Okay, so you get how many times can you tap between the beam during the game. I'm glad I set up this the blue tack here because it's the shonkiest way to lay the board out, but I think it's quite nice. I'm using 2 fingers, so I'm kind of...
cheater. I mean, it doesn't matter. You'll be able to beat me.
This is totally cheating.
It's not.
But I'm breaking the beam.
Yeah,
I'm also leaving dents there.
you have 3 seconds. 2, 1.
Wow.
199. Okay, let's see,
199.
where did you rank? You rank at Chrissy.
So I'd be 4th. One thing I did notice, if you go back to the code and the graph almost tries to log the score, but for some reason it isn't. I wonder if we did score : and time remaining : it might have a better chance of visualizing these numbers. I don't know how it chooses what it does and doesn't visualize here. I think the way it graphs depends upon how the string is. No, that doesn't make it... Okay, I don't know. I don't know what criteria it chooses on what it graphs or not. Okay, do you want to have a go?
I'll have a go.
I'll hit the play button for you.
Okay.
You ready?
Okay.
Gives you a good 30 seconds to do your timing. Oh wow, okay, yeah, your method is working.
Oh!
97 7.
Oh, come on! 2 points! 2 points!
Right, we should get the gamer in the house to give this a go. Jonathan!
Mr. Gamer, come and
You're a
play our
gamer.
game.
Alright, what do we want you to do? We've got a game for you. Stand here, and the game is this. The game will beep. Yeah, you put your fingers between these 2 sensors, which is a beam sensor, and every time you break the beam, it counts. So that means every time you tap the finger, it's going to count the finger taps between the sensors. And my score is 199.
Mine is 197.
You're going to see how well you can score. You've got 30 seconds to tap from when the
After
beep
the beep.
starts.
After the beep.
Ah, he's got technique. Let's have a look.
He does play a lot of games.
He's got 16 seconds left. Seven seconds left.
Man, I should have tried this tactic earlier.
Oh,
Doing
he got
it for-
148.
Was it good?
We got more.
I got 199. I am
I
the
got
winner.
197, so I'm at least mid.
Activity 3. Break beam target score game.
So more games. Okay, let's have a look. Setting target score. So we're going to use a variable and some if statements. If score counter, for example, one of the LED if statements looks like that. If in ifs. If statements inside an else statement. This is fine as a nested if statement. The code, the cool stuff. So stuff red, amber, green. We all know those are wrong. Buzzer frequency, start time, whole ton of variables. It's similar thing.
Very similar game, but I think it gives you a
Output.
how many seconds you got left for things to happen, and it kind of puts it out on the lights.
Okay, let's have a look.
Mm-hmm.
We can have a look. Day 10, game 2.
Mm-hmm.
Oh, I forgot .pi. 0, 0, 0, get 0, get 0, get 0. Oh, we all know that.
I think my technique has shown its
Well,
Oh, okay, so you've got to reach 100 out of 100, and it says,
200.
so, hold on, so we got score, 100 out of 100, time remaining 16. Well, no, we could go with the same target score.
no.
So time remaining 16, yes, but you can challenge me on the same. How so can you get
Okay,
it with less than
fine.
16 seconds?
I
remaining?
accept your challenge.
Go. No. LED goes green, and then red. Right, it probably would have been green, red, yellow, green, but that's fine. Oh, Dean, you won.
And what
You
about
took
game?
12 seconds. So, Jonathan, now you've got to do a number of taps to beat a timer.
So you have to do taps.
So you got, so you're going to see how quickly you can get 100 taps. Are you ready?
That counts actually.
Yeah, that counts.
Quite slow, but
John, our resident gamer, did not see the technique we all used.
Nope.
that's just not changing.
Okay, you took
Okay,
19 seconds. Should we show John? We should show John our technique.
I'll show him.
Do you want to see our technique, John? Ready?
Well, I only used
Go.
one hand. Okay, I only used one hand. Wow. You're only meant to use one finger.
No, you're not. That was never stated. There were never
wow.
rules. I took 8 seconds.
8 seconds. through
Okay,
life.
8 seconds.
Right, cool. So I think, is that the last
I
part
think
of
I'm
the
a
day?
better gamer.
So after this,
See, is this day 10 complete? Yay!
day 10 complete.
That was really fun.
That was fun. I'm wondering if we can make it so it kind of taps its way through a tune. And we can kind of like...
Yeah, go ahead.
Right.
Did you just name the buzzer Tim? Tim the buzzer.
No, I said blue tacked in the buzzer, not Tim the buzzer.
You said Tim the
It's
buzzer.
now Tim the buzzer. It will be Tim the buzzer tomorrow then. Right.
Yes, it will be Tim the buzzer today.
And let's see. So I'm going to take... Let's just take our beam broken code.
Yep.
Day 10 taptones.py
You put it in tone.py.
Tone.py,
You can
okay.
just do import tone.
Yes, we can. After import time, import tone. We can say song equals... I'll just work on a song for a minute. Right, we have a bunch of song notes, but I've not stuck any delay times in here. So we'll now do something like current note equals 0. And every time we tap, we'll say tone.playtone song current note. We'll do volume is 10,000 and a delay of 0.1. But we'll make the end delay 0.
So that we can choose when. I'm testing this. This sounds fun.
Plus equals 1. We'll say if current note is greater than or equal to length of song, current note equals 0. Okay. Yeah. We need to put the word tone in front of each of these notes. What I was wondering actually is if we make it do a toggle thing so we can go a bit quicker, but maybe not. We'll see. We'll see how this works.
Nah. What?
Right, let's try this.
I'm trying.
So you should be able to tap a song with tones. Haven't pressed play yet. Let's press play. Oh, hold on. Has no attribute play tone because I called it play. We discussed this. You said call it play tone. I called it play and then I forgot.
Wait, what song is this? Wait, play that again.
Oh, I see that G needs to be a G1, not a G2.
This is really hard to control.
So really we want this to toggle, I reckon. You might be able to vaguely tell which tune we're trying to make here. So you tap here. Yeah, there we go. That was my fun little music foray for today.
I think that was pretty fun.
Cool. And we found a lovely new way to bodge a circuit with all of these bits stuck down with blue tack over here. Lovely. Well, I hope you've enjoyed today.
Go make stuff and be awesome.
Bye.